So hi everyone and welcome back to the channel. Now I don't normally do aviation videos, but on this occasion it's particularly interesting because I think it's actually a miracle, and I don't really believe in miracles. I tend to just look at engineering and physics, but I can't remember anything like this in my lifetime happening where miraculously everyone on board such a bad incident has survived. The closest thing I can remember is the China Airlines flight that landed in Hong Kong in a typhoon. I think it was back in the end of the 90s. About 315 people on board, and I think only 3 people died. That was a miracle, but this is similar. And what's funny is very different kind of weather conditions on the whole, but the wind conditions and the wind direction was more or less the same. But 2 very different aircraft, 2 very different scenarios. But let's focus on this one. And also, you've probably all seen this video now. This is from another aircraft holding just off of runway 23. Now, runway 23 is on heading 237. And just before we get into this, I'm not a pilot at all. I have very limited flying experience. I was in cadets when I was younger, and I also flew in the RAF a bit whilst at university. But apart from that, I'm just taking interest in aviation, and I'm a qualified mechanical engineer. So I'm really interested to see the structural integrity of how this fuselage didn't snap in half. And now no one fell into a burning ball of flames. Now, I can use quite typical language because, like I said, no one died. There are things in this that I'm amazed by. Someone was looking down on these guys, and credit to the emergency services and the cabin crew, and to some extent pilots for getting away with this. We'll get into the data of the descent rate and the sink rate and the VREF, the landing speed and everything in a minute, but you can see it looks like the right-hand wheel touches down first, and this is a seriously heavy landing because look at the wingtip deflection on the kind of port side or left side winglet. It's normal to get that deflection on a hard landing, but this is quite substantial. And I've put this down to quite a slow speed. We'll just run it through again. And that's quite a heavy landing. Now, basically what looks to happen is the right gear either collapses or the kind of mount where the trunnion goes into the spars of the wing, that area collapses. And I think that's what's most likely happened. When you look at the structure of the trunnion and the main strut itself on one of these, it's a seriously heavy piece of metal. It's so chunky, in fact, it doesn't even need its own separate drag link. It mainly is just has a side link to support itself. And I think it's probably the mounting area where this trunnion piece at the top connects to the spar box. That's probably the bit that's failed. And then what happens? Well, when that gear or the wing spar box area where that trunnion mounts to has failed, the wing obviously collides with the ground. You get a lot of fuel coming out. Luckily for the passengers, that wing quickly separates, and the main fireball is left behind. And then because you've only got one wing left, there's a massive imbalance. You've still got a lot of lift on that wing, and it starts to roll over. Now, we also get, after the impact, when it's ditched the starboard or the right-hand side wing, because this is a rear engine aircraft, the center of gravity shifts back massively. So we get this slight nose up pitch because the CRJ has changed, which adds angle of attack to the remaining wing, which just increases the lift on that remaining wing even more. And she rolls over very, very quickly. Now, the polar moment of inertia is basically halved with one wing, so it does go over very quickly, much like an ice skater when they're spinning. They will pull their arms in to spin even quicker. That's kind of what's happening. It's not the reason, but it goes over very quick. And the miraculous thing is that the fuselage pretty much remains completely intact, which is why I'm so interested in this. Now, the CRJ 900 is basically a stretched business jet. It has this weird kind of nose down pitch when it's taxiing, and that might have something to do with it in a minute. But you can see from these pictures, there's very little kind of intrusions into the fuselage as a structural cylinder. Now, it's perfectly round the CRJ cross-section, and it is that way for kind of pressure vessel design as it gets pressured at altitude and depressured. But there's very small doors, very small windows, very few stress concentrations. There's no massive cargo doors. There's no massive inspection hatches. And from this video, I think this is either from the Belfast or the Texas facility, where the main spars join to the fuselage, they do not pass through any of the fuselage. It's all kind of externally mounted, which gives the fuselage a really strong kind of integrity of a unified structural tube. And the weird thing with the CRJ, the Bombardier, is like they actually lengthen it from, you know, the CRJ 600, 700 to 900. I think it's just by basically inserting different spaces. They call it plugs, but more or less there's minimal intrusion into the cabin, essentially into the pressure vessel, which is why it can survive such a heavy, well, it has survived such a heavy impact and not broken up, where you see many other crash landings of other aircraft where the impact will literally just buckle the tube essentially in its weakest point. This is a very sort of unified structure and an interrupted cylinder. Now, we can see in this video here where the landing gear would probably attach somewhere to these front and rear spars. Now, there's a lot of pieces missing in this, but if we look at the main gear actuation, it's obviously mounted in the brute with the wing, not the fuselage, which again has helped the fuselage stay together. If it punctured a hole in the fuselage, I'm thinking of an old regional jet airliner like the BAE 146 or something, that gear was mounted under the fuselage, and if it punched a hole in the bottom of the fuselage flips in two. Whereas we can see here, even the kind of downlock mechanisms, the over-center locks on these side links are mounted way outside of the fuselage. They're in full spars, what we call full spars, in the back of the wing. And fortunately, I think those bits probably detach. I think the main strut will probably be found intact of the right-hand landing gear, and it's the mounting areas which are probably separated, and that's allowed the survivors to survive. Now, that's kind of a bit more about the engineering of what's happened, but let's look a bit more into the kind of layout of the airport and why this might have happened. And we can speculate because no one's died. But yeah, so this is an overview of Toronto. It's 23, the runway in use, and the heading I think is 237. It's about 600 feet above sea level. Nothing special. It's very, very long. It's also an international airport. But the interesting thing that I don't think many people have picked up on is there is a voice recorder of the air traffic controller in contact with the pilot flying or the co-pilot, and he says there may be a blip on the ILS because there's an aircraft in front of it. Now, I think a lot of people have interpreted that to mean turbulent wake from a landing aircraft in front of this, like the aircraft landing in front, which I think is about 2 minutes ahead. It's not that. Basically, what's happened, and if you look at the video that we saw at the start from the aircraft holding just off the runway, they are holding here behind a no-go zone because they'll be in front of the glide slope antenna. Now, an ILS is an instrument landing system used to auto-land a plane or just provide a visual readout in the cockpit if you're visually flying. If you're on the glide slope, which is basically a 3-degree guidance slope for an approach. And there's also a localizer, which is mounted at the end of the runway, as our Korean friends found out the hard way very recently, unfortunately. Now, it's the glide slope, which this aircraft is parked in front of, the glide slope antenna. So we can tell from that video, this aircraft has come out of the general aviation area, which is, not the international terminal. It's where the smaller planes hang out. And he's joining the runway near the threshold around about here. If we look at Google Maps, we can see this is the very important glide slope antenna. Now, on a day like this where they had pretty bad weather, the pilots would pretty much definitely be flying visually and not be paying too much attention. However, if they were for some reason disorientated or a bit snowblind because of the whiteout and because of the blowing snow conditions, and if you've ever driven in blowing snow, it doesn't mean it's falling, it just means it's blowing from the side, just kind of drifting. They may have been using, the ILS readout or the glide slope readout more than they probably should have been. And could this aircraft parked over here be giving them a bit of a blip on the glide slope antenna reading? That's what the ATC controller hinted at. It's probably nothing to do with the localizer, because the localizer equipment is right down this end. So that aircraft wouldn't affect that. And the localizer affects the kind of horizontal positioning to make sure the aircraft is on the center line, which it was. The aircraft was well established on the center line from way out. So it's nothing to do with that. Looking at the sync rate. So the sync rate, from what we can see here about this distance out from the airport, was pretty fast, but nothing too sketchy. So 1,000 feet per minute would be kind of fast jet landing, pretty heavy. But heavy landing on a jet like this would be about 600 feet per minute. And there are some of these data points, it does go above 600 feet per minute, but that would be a hard landing in adverse weather conditions with gusty or headwind, or a gusty plus a headwind. It wouldn't be too out of the ordinary. But then there is a couple of extra data points that have been released since this that show, I think just before the crash, it was at about 1,000 feet per minute, and that would be pretty much out of bounds, or way too a hard landing for an aircraft like this. 1,000 to 1,200 feet per minute is more like fast jet territory for fighter pilots. So did something happen? Did some major wind shear happen right at the last minute where it really started to sink? You can't really tell from this video the sink rate if it increases or not. It's very, very difficult to see, but we can see that, again, this is a very heavy impact on the right main landing gear, which causes something to break. And that spar, that kind of join between the front and rear spar gives way, I think. More likely that than the actual strut collapsing, because they are so overbuilt. It's more likely, I think, to be the mounting area to cause such destruction to the wing, because the wing, as we can see here from this other video, where is it? It's completely gone. It's not as if there's just a hole punch in it. It's detached the front and rear spar from the rest of the assembly. And we can see here from the existing, or the left-hand side gear, it's in perfect shape. It looks to be down and locked. This over-center lock is in the right position. And even the flaps are correct from this, but obviously you can't tell. It might have been severely damaged. But yeah, it's a miracle that everyone got out. Probably helped by the snow on the ground, the added slipperiness reduced the mew of the runway and reduced the frictional heat buildup, and probably alleviated a lot of the fire from kind of following the plane because it's so cold. And yeah, there was quite a lot of, as the plane left the runway onto the grass, it would have been very, very slippery. So a lot less friction, a lot less heat between the fuselage and the ground than they possibly could have been. Maybe it didn't dig in like it would have if the ground was dry. So yeah, kind of a miracle. But the data on the runway, actually, because of the chemicals that they put on the runway, the data on the runway was actually pretty good. The braking data released was only one higher than dry. So good braking conditions. Sometimes they face pure ice, where basically the brakes have no effect whatsoever. But in this case, braking conditions were good on the runway. However, yeah, we know that the aircraft left the runway. The other thing I want to mention is, I don't know if I put this in already, but when you're taxiing one of these, it looks like they're slightly nose down all the time. Got a very weird stance. So a lot of people have said when the aircraft came to land, there was no visible flare, which is correct looking at the footage. The kind of attitude doesn't change, and it hits the ground at the same attitude it was descending at. No flare to bleed off the sink rate. And is that just disorientation from the pilots? What with this blowing snow? Did they think they were higher than they were, and just didn't anticipate? Were they anticipating to visually get a reference from the runway and flare, or were they not listening to the altitude call-outs in the cockpit? Now, they probably would have flared at about 80 to 30 feet. And if they weren't paying attention, or disorientated, or snowblind, they may have just tried to flare too late, because from the footage, it just doesn't appear to have any flare at all. The attitude The pitch just doesn't change at all. Now, just looking at the structure of the main landing gear again, this is a picture of the CRJ main landing gear. Now, between all the CRJs, they don't really change that much. This is the main trunnion structure at the top here. Now, this is in a test rig. This is in a fatigue test rig. So it's actually bolted to this massive solid steel block, both front and back. And there's this what's called the side mechanism, or the side link, where it locks the mechanism down. This is the torque link, which basically stops the wheels turning. Because effectively there's no caster on these things really. So you need that to stop them kind of shimmying. And yeah, there's no real drag link. So the drag forces which act aft when you touch down or when you brake are all basically just supported by the length forward to aft of the trunnion, and that will be impairing a torque on the spars where it's mounted. And I presume that's where it's failed in this scenario. Maybe the downlock mechanism's failed, but it's very rare, I think, for that to happen. Maybe even the stub axles where the wheels mount failed, but it doesn't look like that from the video. It looks like the whole assembly is just pushed up into the wing, so it just suggests some sort of structural issue in the mounting area rather than the lower end of the strike itself. Now, just going back to the landing configuration, from the video, it's obviously hard to tell again, but from the pictures of the poor thing upside down, it looks like everything was configured to land. So all the gears down, looks to be locked. Even the nose wheel took a slam and didn't collapse, which is amazing. And the flaps look to be set, which I think on this is max 45 degrees. Now, the VREF, which is like the landing speed, obviously depends on the landing weight. This probably would have landed quite heavy due to the adverse weather conditions. So it's probably carrying a little bit of extra fuel. So that would affect the landing speed. But what really affects the required landing speed, or what you call VREF or VAT, is the gusts. So we know from the METAR data that it was gusting 35 knots from 270 degrees. Now the runway is at 237. So if we work out the crosswind and headwind component, I think the headwind component's about 29 knots and the crosswind component was about 19 knots. So nothing out of the realm. Like, this should be possible. I think the crosswind limit, the true crosswind limit for the CRJ 900 is 32 knots. So well within the realms of what's possible. But when you have gusting conditions, you need to add that to your safe landing speed, because if the gust suddenly stops, let's say you've got 30 knots gusting, and that 30 knot gust suddenly stops, you've then got 30 knots less airspeed of lift to play with. So you need to basically add some safety factor to your landing speed. Now, you don't just add that because at some point you'll be going too fast. So there's a formula, and I think I've calculated it so the approach speed needs to be about 147 knots if this 270 gusting 35 was correct. Now, if we look at the ground speed data and add that offset, it's about correct, I think, from this point out, about 118 knots plus that offset, because this is given as ground speed, don't forget. So 118 knots plus the offset would be about 145, something like that. I calculated 148, but anyway. So the approach speed looks to be okay. It just started to sink right at the end. Maybe that guff has dropped off, some serious wind shear has occurred, or it's pilot error, or there was something going on with that ILS. Like I said, there was that aircraft that they were warned about that was kind of not right next to the glide slope antenna. Don't forget the glide slope antenna is here, and that holding aircraft was here. You can see on that bit of markings there, that's apparent in that video. Whether that affected the pilot's decision making at the last minute, whether they should have gone around, if they had time to go around, it's all speculation. But fortunately, everyone survived, thank God. But yeah, just like to add my thoughts on that. It's amazing from an engineering point of view how this fuselage stayed in one piece, in one big long sausage, because it is a long sausage, the CRJ 900. How many aircraft have you seen videos of crash landing and fuselage is broken around a stress point, like a door or cargo door or something? I'm not saying this is always going to happen. I think there's a big deal of luck and a slight miracle this has happened, but kudos to everyone that helped evacuate, put the fire out, and yeah, hope we see less accidents in 2025 because, boy, it's been a bad one. Anyway, I hope you enjoyed this bit of departure from the normal stuff on my channel, and let me know in the comments what you think. Cheers, I'll see you in the next one.